Welcome back to my practical introduction to Stochastic Optimality Theory and the GLA. In this part of the class, I will show you how you prepare the files needed for training an OT grammar. While this is one of the most important parts, you want to make sure to have checked certain steps before you start training the grammar. Something that the algorithm cannot do for you is guaranteeing the quality of your linguistic description and generalization. So first and foremost, you have to check your data and answer questions like which the underlying representations of your observations are, which constraints regulate the observed outputs, and if there truly is free variation in the grammar that you want to model. Being sure about the last point is important because you can expect beforehand if constraints will overlap in your trained grammar, which is the case if there's free variation, or if they do not. And in that case, you would expect all of the constraints to be far apart from each other. So once you're confident about your analysis on paper, the first thing you want to find out is the frequency of input-output mappings, which basically means that you count how often an underlying representation X produces its different output candidates A, B, C, and so on. Yet, this is not enough to really get started, because we have to bear in mind that, of course, empirical data will only contain optimal surface candidates, which doesn't tell us anything about members in the competing candidate set. Therefore, adding non-empirical candidates to your tableau is crucial in any OT analysis, be it stochastic or not. In the case of the GLA, its task not only consists of mimicking the relative frequency of input-output mappings, but also in consistently ruling out non-empirical candidates. Also, you have to make sure that every candidate in your candidate set violates some constraint. The reason being that otherwise the algorithm will default to that candidate being optimal. So, if you do have a candidate without violation marks, it could mean that your set of proposed constraints is insufficient to account for the phenomenon at hand, and could need some reworking. Another solution to this problem is simply leaving out the candidate without violation marks, which I do not recommend unless you can say with confidence that said candidate is irrelevant to your analysis. In order to train the GLA, we will need to prepare two external files. The first one is the pair distribution file, which contains the frequencies of input-output mappings. For example, input X was realized as X 30 times and as Y 70 times. The second file is the OT grammar file, which contains your proposed constraints and how many violation marks they assign to particular input-output mappings. You can write both files as txt files. So let's start with the pair distribution file. Create a new txt file and write OO text file in quotes in the first line and pair distribution in quotes in the second line. When prod tries to read this script, this part tells it that we are dealing with a pair distribution file for an OT grammar. The next step is to indicate the number of input-output mappings that you will provide to the program. These mappings are referred to as pairs here. In the toy example we will work with for the purpose of this class, we are dealing with 4 pairs. Another thing to note here is that actually only the number 4 will be interpreted by prod, while the word pairs will be ignored. Nevertheless, I would highly recommend documenting your file in that way for better readability. There will be several instances like this throughout the pair distribution and OT grammar file, so bear this in mind. Now you can start writing the core information of your pair distribution file. You indicate every input-output mapping from your empirical data in the syntax I provided below. First, you put the underlying representation in quotes and then the associated output form in quotes. After that, you put a number that indicates how often you encountered this kind of mapping in your data. An important thing to mention here is that the actual content of the representation in quotes is not important for the file to work properly, as long as you use those representations consistently. So if you're dealing with very complex representations, there's always the possibility of using a placeholder. But again, it is important that you be consistent with it. And this is already the pair distribution file. Since we are going to use a toy example in the next class, I briefly show you the pair distribution file that I created. As you can see, we have 2 underlying representations here, A and B, with A mapping 70 times to A and 30 times to B, while B always maps to B 100 times. Other possible mappings from A or B to C or D are not observed in this toy example. Another important note: the only thing that matters when it comes to the number of times you indicate for every input-output mapping is the relation between those numbers, rather than the actual number itself. In this toy example, I could have multiplied every number by 10, and that would be 700, 300, and 1000, for example, and the result of the subsequent training would have been the same, since, as we will see in the next class, the input-output mapping frequencies will be inflated anyway. What this also means is that ideally you have to be confident that the relationship between the input-output mappings you provide are representative of the system you want to model, and prod will not be able to make up for data that is not representative. Another tip that I have for better readability is commenting your file with exclamation marks, and any comment you make with the exclamation mark will be ignored by the program. Now you want to save this file on your computer for later use, and I recommend you give it a proper name to properly identify the file and distinguish it from other files. Otherwise, things might get messy when you made a mistake and want to go back to the file. Let's talk about the second file you will need for GLA training, the OT grammar file. Again, create a txt file and start the document with OO_text file in quotes and OT grammar in quotes, which tells prod that it is an OT grammar that we are creating. Next, you provide the number of constraints that you think are involved in the grammar you analyze. In our toy example, we will deal with 4 constraints. Then you provide an actual list of those constraints with the following syntax. Constraint 1 to 4 in square brackets, in our case, colon, and the name of the constraint in quotes. The order of the constraint listing is important because you will have to follow it during the rest of the file. I wrote here in no particular order because it doesn't reflect any theoretical statement of constraint ranking, because as we will see next, the ranking of the constraints is provided separately. As far as constraint ranking order is concerned, we now have 2 options. Option 1, set all constraints to the same starting value. This way, the algorithm will have to look for the correct ranking values that model the target grammar. Or option 2, choose the starting values according to your hypothesis. And this way, the algorithm should stabilize the ranking values by minor adjustments. We will go with option 1. So we add the same starting values to all of the constraints. As in the previous class, I randomly chose 100. Note that we actually have to provide 2 values for every constraint, the first of which is the ranking value, and the second is the so-called disharmony. Disharmony is defined as the ranking value plus noise, but actually we won't have to worry about this value, so we will just repeat the ranking value for disharmony. The next step is indicating the number of tableaus you will be using, which is equal to the number of underlying representations that you find in your analysis. In our toy example, we have 2, A and B. The final step of writing the OT grammar file is listing the tableaus. Since we set all of the ranking values to 100, this part of the file will only inform the program of the amount of violation marks assigned to the candidates by our constraints. The syntax is the following: input, the number of the input in square brackets, colon, and the name of the input representation in quotes. It is very important that you use the same names for input representations and potential output candidates as the ones you used in the pair distribution file, because the files will later be matched in the training period. Then you provide a list of the candidates in that tableau with a very similar syntax: candidate, number of candidate in square brackets, colon, and the name of the candidate in quotes. Then you add the number of candidates next to the input representation, which is 4 in this case. And lastly, you list the number of violation marks that each constraint you previously mentioned in the file assigns to the candidate in question. Since this is a toy example, I randomly chose the numbers for this grammar. And while doing this, you will have to respect the order in which you listed the constraints at the beginning of the OT grammar file. In this toy grammar, I listed the constraints in the following order: C1, C2, C3, and C4. This means that, for instance, C1 and C2 assign 0 violation marks to candidate A, C3 assigns 1 violation mark to candidate A, and C4 assigns 2 violation marks to candidate A. This is also a good opportunity to check if every candidate in your grammar has at least 1 violation mark. If this was not the case, you would find a row with just zeros next to a candidate, which would mean that you would have to improve your analysis and redo both the pair distribution file and the OT grammar file. Taking this as a template, we can easily create the tableau for input B. And again, I randomly chose the number of assigned violation marks. And it's done. The pair distribution file and OT grammar file is all you need for training the OT grammar. I want to mention again that the pair distribution file will be used to generate a training dataset, which means that effectively the number of observations will not be the same as the ones you provide, based on your empirical data. Yet the relationship between the numbers you provide will still be present in the training set. So actually, the observations you report are merely occurrence probabilities of specific mappings to the GLA. Each input-output mapping of the generated training set will then be fed into the OT grammar file, which will cause each constraint function to move according to the mechanisms we covered in the last class. To put it shortly, the pair distribution file is the representation of your empirical data, and the OT grammar file is the model you want to train. Lastly, I recommend you read this paper by Paul Boersma, which I forgot to mention in the previous classes, which also provides an explanation of how to prepare the files needed for OT learning in prod. And next lesson, we will see how training is performed in prod using the toy example we created in this class.